Hey, what's up, guys? Okay, so yeah, so today let's talk about a very simple topic. Probably not very simple, but yeah, some quant interview question I ask. Somebody asked me this question. So pi to the e and e to the pi, which one is larger? I mean, you can check out online. There's plenty of videos. So I would like to make my own. Okay, so this video should kind very short. So I will talk about the short version and talking about the long version. Probably you're gonna interested. Well, this problem is like asking what's your power of or what's your tool of mathematical analysis, and right. So maybe one can guess something. Okay. But the quick solution is that okay, so the quick solution, if you know nothing about the computer science, or the Taylor series, you obviously that exponential x is greater than 1 plus x, right? When x is greater than 0. Okay, so the weird part is that you can just put x equals to pi divided by e minus 1. Okay, hopefully you can see this is positive, right? Because pi is 3.14, e is like 2.7 something. Okay. But this can be proved by using the Taylor series. Right? Because e exponential x will like right. So this problem, the difficult part in this problem is that you need to explode, you need to somehow use the property of this exponential, right? Otherwise, that if you change this exponential to other things, two or whatever, right? It's not easy to see how to do this, right? So it seems like this property is like uh this property is like essential to prove, essential to solve this problem. So this is why yeah, okay. So if you do this, I tell you the exponential pi divided by e minus 1 greater than pi divided by e. So which is exponential pi divided by e greater than pi, right? Because this one is exponential pi divided by e times exponential minus 1. Okay, so you get exponential pi greater than pi e. Okay. Okay, so exponential pi greater than pi to the e. Okay, finish. Okay. You might okay, so the answer will be this. Okay. So this is like the first solution, which should be very simple to you if you believe my proof, right? Entire series x greater than 0 and point oh, right? Amazing. Okay, but what's like if you don't know this proof, right? What's your general strategy? Okay, so maybe one can argue the following. Okay, so one can argue the following. So in general, if you want to prove that some guy, right, some guy, if you want to say something like this, right, you or you may want to check which one is larger, right? The naive way is that I can define f of x and just say that is motion x minus x3. And in order to do the positive or negative, right, the natural way is to do the derivative. So you just do the derivative. And so you already know that f will ultimately greater than 0, right? If it will go to infinity, right? As long as x is large enough. Okay, so the problem is that whether x is large enough, so that this guy will be positive, right? So we want to ask whether x equals to pi is large enough. Probably it's large enough or not large enough, right? So but this is turns out to be this the derivative. Okay. Okay, so the one observation. Okay, maybe let's see. Okay, so one observation is the following. One observation is that if I consider this function, maybe I consider first function is called f1, second function is called g1. Okay, so this f1 is the exponential, right? And this is polynomial. So the obvious idea is that this guy f1 will go here, and maybe g1 will go g1 start here. Okay, so you know that this f1 will always higher than g1, right? As x goes enough. So if you draw this picture, then you will find interesting is that you will find interesting is that when x greater than 0, then g1 and f1, right, the polynomial, single monomial polynomial with the exponential at most intersect twice. Okay, so simply speaking, f1 and g1 at most intersect twice. Okay, so once I know this, then I can say the following, right? I can say that, okay, so I can ask what's these two intersect, okay? So, right, obviously that, so I want to find two intersect. Probably not not simple, right? But, the first thing I know is that when, uh, x equals to 1. So, right, when x equals to 1, that f prime of 1 is 0, right? Because e1 minus e1. Okay. And the second one is probably you can use your eye, right? F prime of e is also 0, right? Because e to the e minus e minus. Okay. So that means what? That means that if I draw this f1, where f1 is like e to the x, and f2 is like x e minus 1 e. Okay, sorry. Okay, so this is like f1, and then this is f2. Sorry, it's a bad drawing. Let's see, this is f1, and then this is f2. Okay, so obvious that this will be 1, this is e. Okay, so where's pi? Right, pi is here. Pi is here. Okay, so this tells you that f prime is greater than 0 when x greater than pi. That's greater than e, right? Obviously that when x greater equal to e, then your f1 that your f1, right, will be your f1 will greater than f2. Okay, so which means that when which gives you the obviously, right, x or exponential pi will greater than that pi e minus 1. Okay, and this is not what we want, right? But you know that this derivative is greater than 0 when x greater equal to e. Okay, so which tell you that the original function f, right? The original function f of x minus, let's say, f of pi, sorry, f of e. So I can use the mean value theorem. This x to, let's say, consider x greater than e. So mean value theorem tells you that there will be some derivative c belongs to e and x, and then this is x minus e. And f of e is 0, right? Because f of x is x e to the x minus x to the e. Okay, so it's 0. And the derivative is 0. Okay, great. Its derivative is greater than 0, and x minus e is greater than 0. So this guy is greater than 0, this guy is greater than 0. So that means an f of e 0 tell you that f of x is greater than 0. So, which means that if I plug x equals to pi, then I immediately get the e to the pi greater than pi to the e. Okay, so the proof is very simple, right? So proof is using the derivative. This guy is 0, and then this guy is greater than 0, and so f of x is greater than 0. So I come out here and come out here. Finish. Okay, so very simple proof. Yeah, so hopefully you guys like these two ideas. Maybe this idea is so like weird. Okay, see you guys next videos.